Okay, we're going to start off in Chapter 1, and to begin, we're going to learn the names and abbreviations for commonly used units in science. So we'll go over the units of length, volume, and mass. So frequently, if a number is given without a unit, it's hard to understand its meaning. For instance, if you were an EMT and somebody asked you how much blood has this accident victim lost, and you just responded by saying 3. Is that 3 drops, 3 milliliters, 3 liters, 3 pints? There's a huge difference. That number, if it's just 3 drops of blood, means something very different than, say, 3 pints of blood. So, in science, when we see a number, we also need to put a unit with it. And we will see this a lot more in lab. So, if you put 3 down on your paper, is it 3 milliliters? Is it 3 grams? Is it 3 centimeters? So, the commonly used units that we use are SI and metric units. So, the standard units that scientists have agreed upon are SI. So, these are System International units. So, System International units. There are also metric units that are used in science as well. So we're going to learn both the SI units and the metric units for mass, length, volume, temperature, and time. So the SI unit for mass is kilogram. And it's abbreviated with a lowercase k and a lowercase g. The metric unit is the gram, and that is just, the symbol for that is a lowercase g. The equivalent, we'll get into this a little bit later in Unit 1, but the equivalent is kind of another word for conversion factor. So it gives you an idea of how a kilogram is related to a gram. So 1 kilogram is 1,000 grams. Okay, so now on to length. It turns out that both the SI and metric units are the same for length. Both use meter, which is a lowercase m. Just to give you an idea of a meter, how big a meter is, we commonly use feet here in the US. So 1 meter is equivalent to 3.280 feet. And again, we'll get into these conversion factors a little later on in Unit 1. Okay, volume, the SI unit is a cubic meter. And remember that volume is length times width times height. Remember that from math. If you don't know, big deal. But it kind of gives you an understanding of how the SI unit is generated, because if you have a cube and you measure the length, the width, and the height, and then you multiply those all together, you will get the volume. And if you had units of meters on all of those, you would have your units for volume end up in meters cubed. So it's a lowercase m and then the exponent 3. The metric unit for volume is the liter. So you guys are probably familiar with this. If you think of a 2-liter of pop, that is a unit of volume. And it turns out that 1 cubic meter is the same as 1,000 liters. Okay, temperature. The SI unit for temperature is Kelvin, which is abbreviated with a capital K. And then the metric unit for temperature is Celsius degree. The abbreviation for that is a degree symbol and then capital C. And 1 Kelvin is the same size as 1 degree Celsius. Both the SI and metric units for time are the same. They use seconds. So now we're going to talk about the difference between mass and weight. So you kind of hear these terms thrown around, and you might think they're the same, but it turns out that mass is the quantity of material something contains. The quantity of material an object contains, whereas weight is the gravitational pull on an object. So the mass of something, if you went from the Earth to Jupiter, wouldn't change. However, the weight would, because the gravitational pull on Jupiter is much larger than it is on the Earth. So just keep that in mind. You know, if you were to choose a place to be weighed, like, you certainly wouldn't want to be weighed on Jupiter because you would weigh a lot more, maybe 1,000 pounds versus 100 pounds. So just to give you an idea. So the difference between mass and weight. Mass is the quantity of material or matter an object contains, and it's the same regardless of the gravitational pull, whereas weight is dependent on the gravitational pull. Okay, so these units that we've discussed, you should be familiar with the SI and metric units for these quantities. The conversion factors we will go over a little bit later on, so don't worry about trying to memorize those, but do be familiar with what units are used for the SI and the metric units. So moving on, we are going to learn about prefixes for metric units. And you've probably come across these before, so I highly recommend that you memorize these symbols and then the base unit multiplier. I'm going to show you some tricks to convert from one prefix to another. So, you know, once I've shown you those tricks, it's probably easier for you to memorize and learn these prefixes, but I can't emphasize, these are very important prefixes. I can't emphasize enough, that's what I meant to say. These are very important prefixes, and we will use these throughout the semester. So we'll see them a lot in lab, we'll see them again in Unit 2 and in Unit 5. So make sure you understand these. So I'm going to fill out this table with you. The first prefix we're going to use, or we're going to learn, is mega. The symbol is a capital M. And it's very important in chemistry to clearly denote the difference between your capital letters and your lowercase letters. Okay, so mega, the base unit is multiplied by 10 to the 6th, or a million. An example would be 12 megameters. So mega, the abbreviation is capital M, and then meters is a lowercase m. Okay, and if these base unit multipliers are confusing at this point, stick with me because I'll show you how to convert from one to another, and it will probably make more sense at that point. Okay, the next prefix is kilo. This is a lowercase k. The base unit is multiplied by 10 to the third. An example would be 3 kilograms. So lowercase k, lowercase g. The next prefix is deci, and that base unit is multiplied by 10 to the negative 1. So you notice that mega and kilo don't have negative exponents. They have positive exponents. So really that means you're multiplying it by a larger number. This is, whereas deci, you're multiplying it by a smaller number, or a tenth. So it's multiplying by a tenth. So mega and kilo are different from the rest of the prefixes that we're going to learn. They have positive exponents. Okay, so deci, an example of that is 4 decimeters. So lowercase d, lowercase m. Centi, 10 to the negative 2. 0.01 is the multiplier. So you've probably heard of centimeters. An example would be 3 centiliters. The abbreviation for liters is a capital L. Okay, milli is 10 to the negative third. That's 0.001. And an example is 10 millimeters. Micro, kind of a U with a tail is the symbol for that. The base unit is multiplied by 10 to the negative 6, or 0.0000 5 zeros. And that is, an example would be 8 micrograms. And then the last one, nano, 10 to the negative 9th is the base unit multiplier, so have 8 zeros after the decimal, and then 1. And an example is 3 nanograms. So these prefixes are very useful when you have numbers that are too large or too small to use a normal unit with, so just grams or liters or seconds. So instead of writing all these zeros out, you can just use milliliters or megameters. So this number here, 0.000002 meters. It's inconvenient to write out that many zeros. You know, if you were writing your lab data in a notebook, it would just get tedious to write all those zeros, and you might forget some sometimes, so it's a lot easier to use a prefix. So what we want to try and do is figure out which prefix could best be used to represent this number. So since it's a small number, we're going to look to the prefixes deci, centi, milli, micro, and nano. So we want to try and find a prefix that has roughly the same number of zeros as this number. So if you look, I'm trying to find something that has about 1, 2, 3, 4, 5 zeros. And look, we have exactly the same number of zeros. So it's going to be a direct conversion. And like I said, I'll go over these conversions in just a second. So 2 micrometers would be how you could represent this number without the zeros. If you look at this next number, 6 million grams, okay, it's inconvenient to write out all those zeros. So if you count the zeros and try and match them up with a prefix base unit multiplier, so we have 6 zeros. Looks like you have 6 here. So the same number of zeros, so we can just say this is the same thing as 6 megagrams. It's a lot easier to do that as opposed to just writing out 0 after 0. Okay, so we're definitely going to be using these prefixes a lot. Now we're going to learn how to convert from one prefix to another. And this prefix ladder that I'm going to show you can be very helpful. One of the nice things about this is if you're taking a quiz or an exam, you can just write this ladder at the top of your quiz or exam, and it will help you a great deal. So, to fill out this ladder, we're just going to fill in the same information that we did on the table on page 2. So to start, the block furthest to the left is mega. And remember that the abbreviation for mega is a capital M. And remember the base unit multiplier is 1 million. Okay, so mega, you multiply the unit by 1 million, or move the decimal 6 places. So I'm going to put 6 at the top and circle it. Kilo, remember the symbol for kilo is a lowercase k, and the base unit multiplier is 1,000, or 10 to the third. So you move the decimal 3 places. So these numbers that I'm putting at the top of the ladder will make more sense in a few minutes. So then we have the basic unit on this ladder. And what I mean by basic unit is it could be grams, it could be liters, it could be seconds. It's whatever your base unit is. So whatever you're measuring, volume, mass, length, time, distance. So it could be any unit. So it's just whatever is after the prefix. Okay, after the basic unit we have deci, which is a lowercase d, and that is 0.1 for the base unit multiplier. So you're going to move that 1 to the right. And like I said, I'll explain these in a second. Centi, lowercase c, 0.01. Move that 2 to the right. Milli, 0.001. 3 to the right. Micro, remember it's that U with the tail. You can move it 6 to the right. And then nano, lowercase n. It's hard to fit that all in. 2, 4, 6, 8. Right, that's going to be 9 to the right. Okay, so I'm going to go through these examples 1 through 4 with you, and we're going to use this ladder. So the question asks to convert 1,000 milligrams to grams. So grams is our basic unit. So, on the ladder, we're starting off at milli. So we're starting off at milli, so right here. We need to get to our basic unit, so we need to get here. So, we have 1,000 milligrams here, and we need to find out how many grams here. So on this ladder, we're going to go from here to here. The way we do that is to move the decimal point 3 to the left. So I got the number 3 because it's written above. the basic unit, it's going to be 3 to the left. So move decimal 3 to the left. So currently there's no decimal point. It's not explicitly written, but it's implied that it's right here. So I'm going to move this decimal 3 to the left. So move it 1, 2, and 3. So that gives me 1,000 milligrams is 1 gram. Okay. Now let's try going the other way. So I'm going to erase what I just wrote so it's not confusing. Okay. And number 2, the basic unit is the liter. So remember, the basic unit can be anything. It's whatever you're measuring. So in this question, we're trying to get from liters to milliliters. So we're starting off at the basic unit, and we want to get to milli. So we have 1 liter here. We want to get to how many milliliters is this? So in order to make that conversion, I need to move the decimal 3 to the right. All right. So the decimal, not explicitly written, but it's right there. So I'm going to rewrite this over here so you can see. Okay, I need to move that decimal 3 to the right, so I'm going to go 1, 2, 3. And I'm going to fill in those holes with zeros. So 1 liter is 1,000 milliliters. Okay. So number 3, 160 centimeters to millimeters. So our basic unit is the meter. We are starting off, I'll do this in a different color. So do number 3 in green on the ladder. Okay, so we're starting off at centi. So we have 160 centimeters. And we need to figure out how many millimeters it is. So we're moving from here to here. So if you look at these numbers, we're just moving from 2 to 3. So you need to move the decimal. We're going from left to right. So you need to move the decimal 1 to the right. And the way I came up with 1 is because there is difference of 1. So 3 minus 2 gives you 1. And we're going to have a lot more practice problems on this, so just stay with me. I know it can be challenging at first. Okay, number 4, 250 meters to kilometers. I'll do this one in purple. So our basic unit is the meter. And we're starting off at the basic unit. So we're starting off right here. So we have 250 meters, and we need to get to here. So how many kilometers? So we're going to look at the number above kilo, and it's 3. So we're going to move the decimal number above 3. And since it's to the left of the basic unit, we're going to move it 3 to the left. Okay, so the decimal is currently here. So 1, 2, 3. So we get 0.250 kilometers. Okay. So numbers 5 and 6 ask you to compare these quantities, and they're not in the same units. So it's typically easier to compare these numbers if they're in the same unit. So you need to either convert them to the same prefix or to the same base unit. So 56 centimeters and 6 meters, you can convert 6 meters to centimeters, or you can convert 56 centimeters to meters. Either way you prefer. You just have to convert one to another. So I'm going to convert 56 centimeters to meters. So I'm starting off at centi, and to get to my basic unit I need to move it 2. So I'm going to convert this. So I want to figure out how many meters this is. So I need to move it, the decimal 2 to the left. So 1, 2. So it's 0.56 meters. Compare that to 6 meters. Six meters is definitely greater than 0.56 meters. So this is greater. Okay. All right, number 6. You can kind of see how converting to the same units makes it easier to compare the sizes of the number. If you look at number 6, we have grams and milligrams. So again, you can convert one to another, just have them in the same unit. So 7 grams to milligrams, that's what I'm going to do. So how many milligrams is this? So we're starting off with the basic unit. We need to get to milli. So I'm going to move the decimal place 3 to the right. So 1, 2, 3. So our comparison is 7,000 milligrams versus 698 milligrams. 7,000 is definitely greater than 698. Okay, so if you're still having trouble with these prefix conversions, don't freak out yet. There's a whole nother page of practice problems. So if you turn to page 4, I want you to practice writing the correct abbreviations for the units. So I want you to go ahead and hit pause now, or pause after I hit speaking, after I quit speaking, and I want you to write the abbreviation for numbers 1 through 9. So hit pause now. Okay, so number 1, kg, lowercase k, lowercase g. I'm going to go ahead and highlight the base units in all of these just so it's clear what we're dealing with. So gram is the basic unit, kilo is the prefix. All right, number 2, M, capital L, lowercase m, capital L, and the base unit is liters. Number 3, kilometers, lowercase k, lowercase m, base unit meter. Number 4 doesn't have a prefix, it's just meter. So, sometimes students get confused and they see the lowercase m and they think, oh, that's milli. But you're never going to see a prefix without a basic unit. So, when you just see m alone, it means meters. So I'll highlight this since this is the base unit. All right, number 5 is millimeter, lowercase m, lowercase m. The base unit is meter. Number 6 lowercase c, lowercase m. Base unit is meter. Number 7 doesn't have a prefix. It's just the basic unit. So gram. Number 8, capital L for liter. So be careful with liter. It's easy to confuse that one and put a lowercase l. Liter is always abbreviated with a capital L. And then the last one is milligram. Lowercase m, lowercase g. The base unit is gram. Okay. Now for the rest of these problems, 1 through 15, you're going to be using your ladder. So I think it's easiest if you write out your ladder, and write out. So if you write out your ladder, you have that information there. It's very handy. So I'll start on number 1. So 2,000 milligrams to grams. I'm going to start off at milli, and I need to get back to the basic unit. So I'm going to move the decimal. 3 to the left. So 1, 2, 3. So 2,000 milligrams is 2 grams. Later on, when we learn about significant figures, we'll learn whether to keep these zeros or to leave them. If you write the number 2 like this, for now it's fine, or like this, it's fine. We'll end up finding out that this is the correct answer based on sig figs, but don't worry about that now. Just focus on trying to convert the prefixes to the basic units or whatever these questions are asking you. So I want you to work on problems 2 through 15. Use the ladder method, and when you resume the lecture, I will have the answers up. So I want you to hit pause now and work through 2 through 15. Okay, so number 2 is 5,000 milliliters. Number 3 is 160 millimeters. And underneath these, I've written how many times you need to move the decimal and in what direction. Number 4, 104,000. Number 5, 0.198. Number 6, 2.5. Number 7, 4.8. Number 8, 0.075. Number 9, 65,000. Number 10, 5,600 grams. Number 11, I'm going to rewrite this so it's a little clearer, 0.50. Number 12, 63. Number 13, 0.8. Number 14, 560. And number 15, 0.120. So if 1 through 15 gave you trouble, there are more practice problems in that pink booklet that I gave you. I highly encourage you to practice these. These can be a definite problem area for students, and if you need help, ask for it sooner rather than later. Okay, for 16 through 21, these are the equalities that you just have to convert one unit to the other. So I want you to go ahead and convert the units, and then we'll compare the size. Okay, so I've gone ahead and converted one of the units to the same. So in number 16, you have 63 centimeters versus 600 centimeters. So 600 centimeters is definitely a lot larger. So I'll put the greater than sign that way. Number 17, 5 grams compared to 0.508 grams. 5 grams is definitely greater. 18, 1.5 liters is equal to 1.5 liters. Number 19, 53.6 decimeters is equal to 53.6 decimeters. Number 20, 0.043 grams compared to 5 grams. 5 grams is definitely larger. And number 21, 3.6 meters compared to 0.36 meters. 3.6 meters is definitely larger. So if these equalities were a little bit more challenging for you, that's okay. You know, sometimes you don't remember your greater than, less than sign. The main thing with these problems is that I wanted you to be able to convert one of the numbers or one of the units to the other unit. So it's basically, we're asking you to do the same thing that you did in the earlier 1 through 15. So again, if you have problems with these, work on the pink book problems. These don't come right away to a lot of students, and practice makes perfect. The other thing about these problems is you can work these problems one day and then the next day work the same problem and not remember how to do it. So, you know, I highly encourage you to work these whenever you get an opportunity. If you're having breakfast in the morning, go ahead and pull out that pink book, pull out your lecture notes. The more you practice these, the easier they will become. And this subject, chemistry in general, it's not something that you're going to get right away. So it takes time, but the more time you spend with it, the easier it will become. So keep it up. You know, if you'll get better at it. And always, always, always ask for help sooner rather than later. So this concludes our first lecture. The next lecture will start on page 5.